Hi guys, today we're going to talk about rotations, another type of transformation. So a rotation is a transformation about a point P. So here we have a point P and we have a rotation that's happening from point A to point A prime. Remember that A would be the pre-image, and anything with a prime, like a little apostrophe, that would be an image, so kind of like the after of the figure. So we're rotating from point A to point A prime. That's the rotation that's happening in this little diagram. So a rotation is a transformation about a point P, called the center of rotation, such that each point and its image are the same distance from P. So we have distances that are congruent. So they're the same distance from P, and such that all angles with vertex P formed by a point and its image are congruent. In the figure that shows the rotation of point A about point P, and then ending at the image point A prime, in this figure, angle AP A prime, so this angle right here, that's just called the angle of rotation. So whenever you rotate, you either rotate in a clockwise or a counterclockwise direction. So if I start somewhere and I go this direction, that's called clockwise, because typically we have our hands moving in that direction. So clockwise is when a figure rotates to the right. Now when a figure rotates to the left, that is called counterclockwise. Counter means against or back. And so counterclockwise means against clockwise or back in the other direction. Now I know that we do have a figure of a clock here. We can see clockwise and counterclockwise, and it makes sense to us when we look at an analog clock. However, when we talk about the rotation of a figure about a center of rotation, we don't necessarily talk about it going from like 12 o'clock to 12:30 or something like that. We don't talk about it in the sense of a clock. We talk about it in the sense of a unit circle. So at the top of my paper, there's not really a whole lot of space, but I want to show you the unit circle because we're going to talk about degrees in a moment. So draw yourself a circle. Okay. And put imagine if you had like an x-axis and a y-axis. Almost like a target. Now, this point right here, we're going to call it 1, 0. We're going to say that this is 1 unit out. This also happens to be 0 degrees. Now, if I rotate from here counterclockwise all the way up to right here, I'm going to end at the point 0, 1. And what angle does this create right here? This angle. What angle measure is that? Well, that would be a 90-degree angle, right? That's a 90-degree angle. Now, if I continue rotating counterclockwise from 0 degrees, say, to this point over here, then I've created a straight angle, and that's 180 degrees. So you'll notice that each time I move from one axis to the next and I rotate, I'm moving 90 degrees. So 0 plus 90 is 90, 90 plus 90 is 180, 180 plus 90 is 270, 270 degrees. And then 270 plus 90, that's going to be 360 degrees. And remember, 360 degrees make a full circle. So 0 degrees and 360 degrees help you land at the exact same point on the unit circle. So the reason that we talk about this a little bit is because some of the important degrees of rotation are listed here. And you do need to know these. So these are something that you want to come back to. But we needed to talk about the unit circle so that you understood where these degrees were and in what direction you were rotating. So the first one talks about a 90-degree counterclockwise rotation. So we're rotating from like 0 to 90 degrees in a counterclockwise manner. So what happens when you move from here to here is that your point x comma y gets mapped to the point negative y comma x. So this point is 0, 1. So if this is xy and this is negative yx, if I take 0 and I make it my x value and negative, which is still just 0, and then I use the same x value as my new y value, well then that kind of shows that I have this point mapped to this point. So this is what happens when you have a 90-degree counterclockwise rotation. Now let's say that you want to look at a 180-degree counterclockwise rotation, so from 0 to 180 degrees. Well, let me see if I can get this all in the frame. This point over here, if this is 1, 0, then this is negative 1, 0. So it says what happens is you take the x and the y value and you just keep them in the same place, but you make them negative. Negative x, negative y. So if I make 1 negative, then I get negative 1. And if I make 0 negative, I still get 0. So that checks out. And lastly, for the degree of rotation of 270 degrees in the counterclockwise rotation, it says that you take any point x comma y and you switch the x and the y and you make the original x negative. So here, if this is 0, 1, then this is 0, negative 1. So you take your original x and y and you switch them. So instead of 1, 0, you have 0, 1, and then you make this negative. So 0, negative 1. So these are just typical patterns that you see for the degrees of rotation. Some notes. Unless stated otherwise, always assume that you're rotating in the counterclockwise direction. Always assume you're rotating counterclockwise. Positive angle measurements are used to represent counterclockwise rotations, which may seem kind of backwards if you're looking at a clock, but if you're looking at the unit circle, to go counterclockwise, to go from 0 degrees to 90 degrees, well, that would be like a 90-degree rotation, and that's positive. So it kind of makes sense that moving in this direction would be positive, and moving in this direction would be negative. So negative angle measures are used to represent clockwise rotations. Okay, so let's move to some examples. Example 1 says draw the rotation triangle ABC with vertices of A at 2, 1, B at 3, 3, and C at 5, 1 about point P at 0, 0, the origin. So this is the center of rotation. And I know that because of this word about. So it's telling you you're supposed to rotate about or around point P. And then by 90 degrees. And because this is positive, that means that we are going in a counterclockwise rotation. Okay, so let me go ahead and plot my points. They're there, but they're not labeled. So point A is at 2, 1. Point B is at 3, 3. Point C is at 5, 0. Oops. And then point P, that center of rotation, is at the origin. So we want to make sure we have that on there. So look back. If you are rotating 90 degrees, That means that any point x comma y is mapped to the point negative y comma x. So you switch your x and y, and then you make your new x value negative. So let's do that here. Let's switch x and y. So instead of 2 comma 1, we have 1 comma 2. And then let's make our new x value negative. Remember that we're mapping this to negative y comma x. So switching x and y and making your new x value negative. So switch 3 and 3, that really doesn't do anything, but make your x value negative. Switch 5 and 1, make your new x value negative. So let's plot our new points. So we have point A prime at negative 1 comma 2. We have point B prime at negative 3 comma 3. And we have point C prime at negative 1 comma 5. So this shows me my rotated figure, my pre-image to my image, and it's because we rotate 90 degrees. You'll also notice that if you were to look at the distance between the center of rotation and the pre-image and image points, it would be the same distance. So this distance is the same as this distance, and the point from P to B is the same distance as the distance from P to B prime, and same thing with C and C prime. Okay, let's look at example 2. Example 2, draw the rotation of triangle ABC with vertices at A of 2 comma 3, B at negative 1 comma 2, and C at 2 comma 1 about the point P, which is at the origin, and by 180 degrees. That's a positive angle measure, so that means that we are rotating in the counterclockwise direction 180 degrees. So I'm going to go label my points on my pre-image. A is at 2 comma 3. B is at negative 1 comma 2. C is at 2 comma 1. And point P, the center of the rotation, is at the origin. Okay, so I go back and I look at my degrees of rotation. If I rotate 180 degrees counterclockwise, then that means I map my points x, y to the point negative x, negative y. So I keep the x and y where they are, but I make their signs change. So I'm going to map the point 2 comma 3 to the point negative 2, negative 3. I map the point negative 1 comma 2 to the point positive 1, negative 2. And the point 2 comma 1 to the point negative 2 comma negative 1. So I'm mapping every x and y to a negative x and a negative y. So let's see what that looks like. Point A prime is at negative 2, negative 3. Point B prime is at 1, negative 2. And point C prime is at negative 2 comma 1. So here is my image. Which looks about right. So I take from B to B prime. I rotate 180 degrees. Okay. So last problem, draw the rotation of triangle RST with vertices R at 3 comma negative 1, S at 1 comma negative 4, and T at 1 comma 1 about point P, which is the origin, by 270 degrees, another positive angle, meaning we're rotating in the counterclockwise direction. And we don't have the figure here first, so we do need to plot it, and I'm going to give you a little bit of time. Please pause your video and try to complete example 3. So hopefully you looked back and you saw on the front page that any point x comma y, if rotated 270 degrees counterclockwise, will be mapped to the point y comma negative x. So we had to switch x and y, and we had to make our new y value change signs. Now, this figure that has kind of solid sides, this is my pre-image, and this dashed sided figure is my image. I did make a mistake right here when I was plotting t prime, but I just x'd it out, so I want to make sure you understand what that is. And then I also want to keep point P as my center of rotation, but I just want to show you from point T all the way to T prime. It certainly looks like I go through 90 degrees, 180 degrees, 270 degrees before I would get back to 360 degrees. So it surely does look like I'm rotating 270 degrees. Okay, last bit of information for our notes today. A full rotation from 0 all the way around is 360 degrees. So we saw that on our unit circle. If we rotate 90 degrees counterclockwise, that would be the same as rotating 270 degrees clockwise. So a mapping for 270 degrees clockwise would be the same as 90 degrees counterclockwise. So that would be x comma y is mapped to negative y comma x. That's from the front page. If you rotate 180 degrees counterclockwise, it'd be the same as rotating 180 degrees clockwise, because 180 plus 180 is a full 360 degree rotation. So the mapping for 180 degrees clockwise would be the same as counterclockwise. X comma y is mapped to negative x comma negative y. And then finally, rotating 270 degrees counterclockwise would be the same as rotating 90 degrees clockwise. So the mapping for 90 degrees clockwise would be the same as 270 counterclockwise. So on the front, that was x comma y is mapped to y comma negative x.